Thank you very much and good evening, and thank you very much, Nina, for inviting me. We met by accident in Silicon Valley a couple of months ago, and we're just discussing what are you doing? Blockchain energy. What does this have to do with energy? And it has been quite a long journey that we are here, and although blockchain is very young, we are a fast-growing team, and half of our team is energy professionals. Part of the energy professionals have been working for regulators, for advisory. I've myself worked for ABB and Andritz on the energy, on the generation side. The other half of us, this is Gavin Wood, Aaron, and Jutta. They were actually the founders of Ethereum, which was just introduced by Alex. So one of the most advanced blockchain technologies, Ethereum, Gavin Wood was the CTO of that, and I want to introduce you at this presentation how this technology will be applied in the energy sector, where we are right now, and where the future will go to. So this story started actually 3.5 years ago when I stumbled over the white paper of Satoshi Nakamoto, where the key point which I understood is we have a way of transacting information, or there is a technology where you can record something and it's immutable to change afterwards. So the idea immediately came up, wait a second, if we can not only shift a number from left to right as Bitcoin does it, but if we can record information in a way that it can never be changed anymore, in energy that is quite huge. So I was traveling around the world and talking to all the core tech developers, and they pointed me to a guy called Vitalik Buterin, who at that time was 19. He just released the white paper of Ethereum, and basically with the founders of Ethereum, we made a deal. I'm going to teach them an energy market, and they're going to teach me Ethereum. And meanwhile, Ethereum was built. We were traveling around the world. We met regulators, TSOs, DSOs in different countries because we wanted to investigate how this technology will be applied in different countries in different unbundling stages. And we came up with 20 business models, and every time we came up with a business model, it was clear for us it is too early to launch the business model because the tech wasn't that yet there, and it was too risky, especially because it was too disruptive. Then Ethereum was launched a year ago. It skyrocketed in valuation from 0 to 1 billion in 8 months. And we realized that actually in all business models, they had one specific thing in common. And so the smallest denominator between them is this tech that I'm going to introduce to you now. And so we decided to form Grid Singularity to, on the one side, to do two things. To develop the core technology further, that this can be applied in the energy sector, and build apps for this system. All right, so Alex has already said pretty much about the blockchain, so I'm going to keep it very short. The classical meme is that it's to ownership what internet was to information, but it's actually way more. And blockchain is actually able to transform the whole internet, how information is transferred as well. So not only ownership. And let's start with a very basic example. I'm talking here to you, and I have private thoughts, and this private thought is my privacy, so I choose my privacy. And you hear my information, and maybe my information is of value to you, you pay me. Maybe I'd give your information, and your information which you give me back is valuable to me, so this is a direct interaction. I have my full privacy, my full integrity. Internet has taught us something different, because there is always an intermediary who takes this information, and he's reselling that against advertisement. So in the normal way of discussion, what we have learned, this is how I learned at least it, is we know money is time. In internet, a piece of information is money. The problem is we were guessing before, we as humans now, we don't know what this information is worth. So we don't know what is your name worth, what is your situation, what is your address worth. We don't know that because this is being traded by somebody else. So in energy, there is a similar approach actually. So in energy, large corporations, they try to figure out, or they try to build business models where they actually copy the same business models as they are on internet. Google, Facebook, and so forth. And so the key issue in this business models is you have to trust them. And this comes actually at a very big price. So if you choose one vendor, it's very difficult to change. There is no interoperability. This one vendor can, at any time, if he's got hacked, you don't have access to your data. And he could, if he got hacked, your data could have been changed. So there is no authenticity of the data. And mostly it's closed source. So what we said, what we want to build is actually, we want to build a system that does not require mitigation of mistrust, which is the biggest cost surrounding us. How do we avoid trust? Well, very simple. If everybody tells the truth, then we don't need to trust. But how do you see if it's true or not? So we authenticate information in the system that we build when information is happening. So it means we save a footprint of it in the blockchain when the sensor is sensing at the same time in real time. And that way we have a single source of truth. And there is a big buzzword coming up, user-centric. We understand user-centric different as most of the people use user-centric, because user-centric means focus on the user, what you can sell to him. We mean user-centric that the user will learn the value of his information and he will decide with who to share which data in specific specific granularity against a specific service. And we want to build this system with the highest security. And of course, I want to capture my value per time. I want to know what it's worth, because everybody of us thinks the internet is free, Google is free. No, we pay it with information, but we don't know what the information is worth. So what we will have to learn, or what the system will change in us, is it will actually teach us what is the piece of information worth for a specific time. There will be a bidding curve for each type of information. In energy, I have, for example, an asset. I'm an investor. I have a hydropower plant, and I want to share this data. So why do I have to connect to somebody who gets all the data permanently and he has only one app? So the system that we're building is actually imitating human interaction, as I said it to you before, with a few improvements. There is no trust anymore, and distance is also not a problem anymore. So this system, which I will go deeper now, is a trustless system. We as a platform provider, we have no idea what is happening there, because it's only in the integrity of each asset owner to decide with who to share his data, and he's only sharing it with the other peer. It's open source, it's completely auditable, that nobody else has access to this data. All right, so how does it work? We have built a data logger. It's considered as a smartphone. And this smartphone is a node on the network. You connect it. We now have reverse engineered 17 SCADA protocols, and it takes 2 hours to connect any type of power plant in renewables to the system. And this data logger, what it does, it's verifying the data when the data is happening, and it's preparing it that you can share it at any given time. There is a SIM card. The SIM card is kind of your master key. Only the person which has the SIM card can decide with who to share the data at any given time. Now, and then there is a kind of a DOS, distributed operating system. And through this operating system, you can access this data. So we're building this platform, World Meter. You go online, and we have now connected 70 power plants, renewables, spread all over Europe. And many of them are actually giving their data for free, because we asked them, would you be interested to provide your data just to let other people build different apps? And so we came up with the idea, why not rebuilding Google Maps for the energy sector? Because now we first time can actually visualize electricity flow. And all this information has been authenticated, means we can validate it if this information, if we ask for all the information, if it has been altered in between or not. So what you can ask the system is, show me please solar power plants which produce electricity in the opposite to each other. And what the system will spit out, it might spit out every time in Chile the power plant is performing, the one in Serbia is not performing, simply because the sun shines differently. If you have that over record over a few years, well, you can ensure the sun by hedging the markets against each other, which means less equity for solar power plants. You log in and you have a browser, which is a decentralized browser. It's not our browser. It's not owned by anybody. And then there is an app store. And this is a few of the apps we have been building, and I just give you some examples. We're building these apps in joint ventures with large corporations. And there is in principle 3 different types of apps. There is apps which are decentralized. This is a smart contract which is not owned by anybody. It just allows people to share information anonymously over ID, and they get a benchmark back. So for example, there is a very simple application. There will be a lot of apps for free. I'm a house owner with a PV on the rooftop, and I would like to know how my PV performs in comparison with my neighbors in a diameter of, I don't know, 500 meters. If I'm underperforming, please send me a message. I might have forgotten to put down the snow from the panels. Free. Another one is asset valuation. What about asset valuation? Asset valuation is simply there because there is no trust. If you have a hydropower plant and I want to buy this hydropower plant, I go to a large engineering office and I ask them, please check the power plant because I don't trust your data if you provide it to me. Well, and we don't have this mistrust here anymore. You can just share the data and the asset valuation just becomes a single app, and which changes the asset valuation business from a one-time business, very high cost, into constant business, which is paid per month. So most of the business models are changing into payment per time. Another one is we built a trading bot in a factory in Berlin, and the trading bot had actually, it's a completely integer agent which was assigned with an asset with the factory, and this agent could not have been, it's impossible to manipulate this agent from outside. It had a task to keep the temperature at the same level, and we connected it to EEX, the energy exchange, and the electricity cost went down by half. It was just training it and leaving it. So we believe there are systems, we not only believe it, we have the proof of concepts for that, that in future, not like in Germany, there will be 270 traders like there is now, there will be 30 million traders. Every household will become a trader, because it's possible to rebuild the whole grid or the whole system from bottom up with a much higher resiliency rather than balancing the grid from the top. So, where is blockchain now? So Gartner says it's at the peak. It's completely overinflated, the expectations. And I completely agree on that, because we debated with our white paper in January, and we made a simple demo. We manipulated a prepaid meter at a public school in South Africa, and I transacted 1 Bitcoin, and 30 seconds later lights turned on. Since then Forbes and Bloomberg and everybody wrote about it, and everybody believes tomorrow we have the solution. The AOL CD is coming tomorrow. Well, that will take another few years. So what do we have now is Bitcoin, now 9 years old. It can only handle maybe 7 transactions per second. 7 transactions per second. If you think of a computer, 7 hertz, that's very low. And confirmation takes 10 minutes. Ethereum already, like the next revolution, 20 transactions per second, 20 hertz, and they call it world computer. This world computer is slower than the C64. So how to run how many billions of signals on this system? This is impossible. So it's completely overinflated. So, but it's enough to make proof of concepts. This is already enough to open the box of Pandora, to learn it, to play around with it, to see how this is going to change business models. And in most of the industries, there have been already a lot of proof of concepts, but every time you do a proof of concept, and you can do it with the current systems with Ethereum, you make a closed environment, and you see, oh, it's working, and then you're puzzled because you don't know how to continue, because you can't roll it out worldwide. The system that is out there, Ethereum, is completely transparent. So it means if you connect any type of house, any coder which can code knows exactly what's happening in the house. So it means we need to improve the system. And improving the system, there is specific technologies we have to improve. We need a much higher output volume. Means we need 1 million transactions per second. Visa is roughly doing 5,000, MasterCard the same. So 10,000 would be enough to cut out this business. But in IoT, we need a much, much higher. Furthermore, we need a confirmation time much shorter. We actually need up to a second, but this brings so many problems with itself. The third one is privacy. We need to build in privacy. And so privacy embedding is playing against transactions per second. So it's a very difficult task, and according to IBM and many other people, there is maybe 10 people in the world which can develop this technology further, the core technology further. So, so what will happen first? All the other technologies which I've shown right now, they are open networks. But in energy, there can't be an open network. It's impossible. Because if you consider apps which touch national interest, which is mission-critical trading of secondary reserve, balancing, you need to know the clear identity of the asset. You need to know how much is really installed. So there is a regulator, and it has a reason why there is a regulator, because it's of national interest. So what will take off first, and here we actually copy, I say we from the energy industry, we copy from the financial industry, is what is happening. There is consortia happening. And the consortia, if you make a consortium chain, you actually define specific authorities which are distributed all over the world, and you define on rules, and you can, if you have authorities, not completely open decentralized networks, you can program the clients to be already very fast and embedded privacy. So this is much easier than doing it in an open network where everybody can hook in and hook out at any given time. So what will actually take off first is consortium chains. In the financial industry, there is already one. There is actually a couple of them. And the first one is R3CV, based in New York. They combine 50 banks, of the largest banks. And now every time there is a consortium built, there is always the same question of the consortium partners, which blockchain to use. What is the basis? Are we using Bitcoin? Are we using Ethereum? What is the next to come? And well, this question is actually obsolete as well, because in a few weeks' time, there will come a new white paper from one of our co-founders. And there is another technology being worked on, which is called multi-chain, which is basically bringing interoperability between all the chains already out there. So it doesn't matter if you have a consortium chain, because with this technology, you can transfer assets between the different chains, between the different consortia, or between the different businesses. So what we decided, and this is quite a radical decision for a startup, we decided that we will bring out the core technology, which is authenticating the data, all the reverse engineered protocols. We will actually open source everything. And we decided to form a utility consortium, which is a non-profit foundation called the Energy Web Foundation. And it's governed by the Rocky Mountain Institute. And the Rocky Mountain Institute is now gathering utilities worldwide to join this consortium, and they're already speaking to 15 of the largest. This is very fresh. This is probably the first time we speak about it. And yeah, that's what we do. We build core tech. We build core tech in non-profit on the one side, and we give it to the foundation. And on the other side, we build apps in joint ventures. And the whole industry, which is very young, just a few months, there is already 20 startups, and we got contacted over 140 utilities in the last couple of months. We can't answer any requests anymore. We decided to consolidate this industry in an event in Vienna. And this event will be called Event Horizon. And City of Vienna is paying the Hofburg for us, and 700 people coming. I can highly invite you there. This technology will enhance every business model of every startup out there, and you will see the first application at this event. Thank you very much.